To build our bubble sort algorithm, we will start by defining it as a function, which takes an array as a parameter. And let's call our function down here with an example passed in so we can reference it as we build out the algorithm. The main functionality of our algorithm will be achieved using two for loops nested inside of each other. Our outer loop will dictate how many times we want to loop through our array, which we know from the previous video is the array's length minus 1 times. We will write that by saying for variable I equals array.length, while I is greater than 0, we decrement I by 1 on every iteration, so I minus minus. This will create array.length minus 1 loops for us. We write it in this format starting at the end and decrementing by 1 each time, instead of starting at the beginning and incrementing I by 1 each time, to handle the fact that on each iteration, we will be stopping our inner loop 1 element shorter on each pass. This probably sounds and looks confusing right now, but once we build out the inner loop, it will make a lot more sense. Our inner loop is where we will handle the comparing of each number to its neighbor. So we will write out our inner loop by saying for variable j equals 0, while j is less than I, do j plus plus. Okay, let's break down these loops and what is actually going on here. This outer loop is simply saying, do whatever is inside of here, array.length minus 1 times. And this inner loop is saying, loop through the whole array, and on each loop, stop 1 element shorter than the previous loop. This is to handle the fact that on each pass through the array, we know that the largest element bubbles up to the top, so we can stop earlier and earlier on every consecutive pass. Our code is stopping each pass earlier than the previous one by only running this inner loop while j is less than I. Let's do an example with our array down here to understand this better. On our first pass through the array, I equals 6. So our inner loop runs the whole array, switching every element if necessary, until the biggest number is bubbled up. On our second pass, I equals 5. So our inner loop passes through every number in the array, stopping 1 position earlier. Now our 2 largest numbers are in the correct positions. On our third pass, I equals 4. So our inner loop stops 1 element earlier, at position 3, because that is the highest it can go, while j is less than I. And so on. That is how we handle the fact that we need to stop 1 element earlier on each loop through our array. Great. Now the only thing left to do is build out the functionality to switch neighboring numbers if necessary. To do this, we will use a temporary variable like we did in our reverse array in place algorithm. So in our inner loop, we will say, if array at position j is greater than array at position j plus 1, then we want to switch them. So to switch them, we will say variable temp equals array at position j. Then array at position j equals array at position j plus 1. And finally, array at position j plus 1 equals temp. And that will correctly switch our elements if it is necessary to switch them. The last thing that we have to do is return our newly sorted array down here outside of both our loops. And that is it. That is our bubble sort algorithm. Let's test it to make sure that it works in the next video.